So guys, today we are going to deal the last part in the industries what they do in order to get the pure metal. That is by the topic called as refining. So basically, of course we know that, as I mentioned in my earlier video also, once you are extracting the minerals from the earth, first it is subjected to the concentration that we have seen with respect to the different methods. That could be your gravity separation, magnetic separation and all those things. Of course, there we are going to remove certain impurities. Once you have done that part, then we are going to oxidize your particular ores by using, and then we are going to reduce those metals, your metal oxides to respective metals using your reducing agents. So once you have reduced it, of course we have got the metal. But also what happens is there will be certain amount of impurities will be present. But in industries, they will be not encouraging such impurities present in the metal. They want their metals to be in their ultra purest form. So that ultra purest form can be obtained by a technique called as that of your refining. So this is the last technique what an industry do or what a metallurgical process involves in order to extract the purest metal. But in order to obtain or in order to undergo your metals through your refining process, it is having certain categories. That is what it says. This method is employed depending upon the properties of metals and also properties of your impurities. So depending upon these two properties, we are going to see the different types of your refining process, or in simple words we can say that different techniques of your refining. So another first technique let me go with, which is called as distillation. If you are remembering, when we were extracting the zinc from zinc oxide, of course I chose the coke as a reducing agent. But also along with that, I also said that whatever the metal is there, it is first distillate and then you are getting your metal by your rapid chilling. If you are marking my words, I am again using over the word as distillate. Why I am using it? Of course, in there also we have undergone that of your distillation process. So whenever you are refining or whenever we are going under this heading of refining, each technique, of course I have said earlier, is depending upon the properties of the metals and that of your impurities. And each technique has a certain principle, which is very much important. So under this distillation, the main principle, what does it say? So this is a technique, that is, your distillation is a technique which could be applied only for your low boiling metals. Low boiling metals. That means what? The metals which are going to boil at a very low temperature. So if you just provide certain temperature range, of course they will start to boil. But what is happening now we have to see. Of course we know that if you have taken a container, just for a general purpose I am saying, and you are having your zinc metal over here. So what we are going to do is we are going to heat it. Of course what happens, the metal will start to boil at a very low temperature. So when it starts to boil, what happens, whatever the impurities will be present in this method, they will start to evaporate and they will be connected into that of your another chamber. So what will be left out in the initial container? Your pure metal. Of course, whatever the pure metal we are going to obtain, they will be remain as that of your distillate. So that will be called as that of your distillate. Of course, after the distillate, they will be somewhat in a liquid state. So I have mentioned when we were extracting the zinc. So this distillate will be solidified with respect to that of your rapid chilling. So this is the technique of your distillation, which will be employed only for your low boiling metals. So what happens when you start to boil the metals, whatever the impurity metals which will be present, they will be evaporated and they will be collected in a different chamber. So whatever the initial chamber will be there, that will be having only the purest metal distillate, which will be then solidified by your rapid chilling. And the examples, that is the metals which can undergo your distillation, of course you can only say me, yes, one is your zinc as we have seen, and also the mercury part. Whatever the mercury ores, they can also be refined through this distillation technique. Coming to the another technique which is called as liquation. It is called as liquation. By the name itself, you're going to get the hint. That is, we are going to deal some with a liquid state. Remember, here the main principle, what does it employ? So here we are mainly employing to that of here low melting metals. Low melting metals. Please do remember, in distillation, low boiling metals. In liquation, these are a technique which will be employed for that of your low melting metals. So what is happening over here is, basically, whatever the metal you are going to choose, they are going to melt at a very low temperature. So what happens? Whatever the impurities which will be present, they will remain as solidified because they are having very high melting point. So depending upon this property, now let us see that how you are going to refine your metal. So how it would be means, you are going to take a slopy, like a slope hearth we can say. Hearth means a slopy surface we can say, a sloping surface is there. So what you are going to do is, of course, if I consider here is your metal. Let me think in this way. Of course, this whatever the sloping surface is there, this is your heated surface. This is your heated surface. I have maintained a temperature such a way that the metal should melt at that temperature. That is, the melting point of the metal has been adjusted on this heated surface. So what happens over here? The metal starts to melt, of course. So when it starts to melt, what happens? It will get liquefied. But whatever the impurities which will be present, they will be what be happened. They will remain at initial point itself. It is similar to that of your ice cube if I say. So take here is your ice cube and put a wall over here so that your ice cube should not come out. And you are going to heat it, let me see. Let us think that in your ice cube, when you are putting in your freezer, put 2 to 3 stones over here. So what happens? Of course, when you are going to heat this sloping material, your slopy surface, of course what happens? Your ice starts to melt. Yes, keep a bowl over here. So ice, when it melts, of course you are going to get your ice water. But what happens to these stones? They will remain there itself. The same concept we are going to say with respect to the metal. So here also we have a blocker over here. So what you are going to do is you are going to heat this metal at its melting point. So your metal starts to melt, and whatever the melted part is there, that will be connected in that of your another container. Whereas your impurities, which is having a higher melting point, that will remain at the initial position itself. So this is the main technique under your refining, which is called as liquation, which can be only employed for that of your low melting metals. If you come with respect to the example, we have that of your tin, yes, and your lead. So these are some of the examples of your low boiling metals which can be refined under the technique of liquation. The most important point or the most important technique we have to remember over here, and is another technique which is called as electrolytic refining. Electrolytic refining. Very much important. Because as it involves some certain chemical reactions, of course in chemistry, chemical reactions has its own role, we are saying it is somewhat important process. So first and the foremost thing, let us understand what is the main principle involved in this method. So guys, what we are going to do is, of course, electrolytic means it should strike your mind that of course we are doing some electrolytic process. We need an anode, that is electrodes will be used. So here also an anode, a cathode, and that of your electrolytic solution will be used. ಅಲ್ವಾ ಯಾವುದೇ ಒಂದು ಎಲೆಕ್ಟ್ರೋಲೈಟಿಕ್ ಪ್ರೊಸೆಸ್ ಆದರೂ ಕೂಡ ಈ ಮೂರು ನಮಗೆ ಬೇಕೇ ಬೇಕು. Now the question arises, what anode, what cathode, and which electrolytic solution you have to use. Of course it is a refining process. So in refining, what I am doing is I have to remove the impurities and I should get the pure metal. So remember, in anode I will be taking my impure rod or the impure metal I will be taking in the form of a rod. Yes. Whereas in cathode what I am going to do, I will be taking a pure metal. Coming with respect to that of your electrolytic solution, what you will be taking? Soluble salt of your same metal. Soluble salt of same metal. Now the question arises that why did I choose anode as an impure metal itself and why cathode as it of your pure metal? Let me again remind you, metals are electropositive. That is, in simple words, if I have to say, means whichever metal you take, they will be having a set of your positive charge itself. True. So when it undergoes, we know that at anode what happens? Oxidation happens. That is, the loss of electrons happens and whatever will be generated from your oxidation part, they will be as set of your cations. Once the cations which will be generated from the anode, where does it move? Of course to the cathode part. So at cathode what is there? Pure metal. So what happens? Whatever the cations will be generated of the same metal, they will be just coming to that of your pure metal and they will get combined over there. So this is a simple technique of your chemistry. Nothing much we have involved over here. That is, let us go with it. For example, in anode what happens? Let us give a general reaction. If I have taken an impure metal, I am going to pass my electric current. So what happens over here? Here you will be getting as Mn plus some amount of N electrons will be given. That is the reason we are saying it as oxidation. So at cathode what is there? Of course, the same metal what you have chosen as an anode, but it will be the pure form. So what it will be having, Mn plus will be there. It is going to accept those electrons and it will be giving you as the pure metal. Let us take an example. As I said, if I want to purify that of your copper metal. So at anode, what I am going to take, guys, you only just suggest me. At anode, I am going to take as it of your impure copper metal. Yes, very good of that. At cathode, what I am going to take? Of course, I am going to take your pure copper metal. Yes. Now the question arises, what you are going to take in your electrolytic solution. What did I say? It should be a soluble salt. Alva, it should be a soluble salt of your same metal. That is, of course, I have taken copper metal. So it should be the soluble salt of your copper metal itself. Of course, we know it. We can take an acidified copper sulfate solution. Why did I choose acidified? Means because it is an electrolytic. Easily it will be connecting, that of your conductivity will be more. In simple words, if I have to say, means electricity conductivity will be more when you use some dilute H2SO4. Now let us see what is happening in that chamber. So let us take over here. Okay, here you have taken, here is your cathode and here is your anode. Let us check. Yes, and here is that of your copper sulfate solution. So what happens over here? Of course, when you are passing it as an electric current, let us take this one as an anode. Anode means positively charged. This is your cathode, negatively charged. So what happens here? Your Cu plus is coming out. If I just take Cu2 plus is coming out. So this Cu2 plus, now what it is trying to do? Since it is now having a positive charge, Cu2 plus is there. So of course this has to be nullified or neutralized. So where does it go now? To that of your, yes, cathode. So in cathode what we are having? The pure metal. So this Cu2 plus will go to that of your cathode. Now the question arises, sir, how can we come to know when the reaction has been stopped? Of course, when you are using some certain colorful solutions, it will be easily observed. Or in simple words, if the solutions are not colored, before doing this electrolytic process, let us measure that of your cathode and that of your anode. Let us take that cathode will be as that of your W1 grams and your anode as that of your W2 grams. So after electrolysis, what should happen? Let me ask you itself. It's a common sense question. Whether cathode's weight will increase or anode weight will increase? Yes. So after electrolysis, of course, what happens? The weight of your cathode will increase because whatever the metal which are present at the anode, they are going and sitting on the top of your cathode, thereby increasing the weight of your cathode. So this is the main process which will be employed in that of your electrolytic refining. Very much important. So at anode we are going to choose your impure metal, as a cathode the pure metal, in electrolytic solution the soluble salt of your same metal. For example, if you have doing with that of your zinc, of course in the anode you will be taking your impure zinc metal, cathode as a pure zinc metal. Electrolytic salt, what you're going to take electrolytic solution, you can take your zinc sulfate, of course a soluble salt it should be, that is the thing, and you can continue the same process. So these are the main important 3 techniques which I will be just closing my video. So in our next video we are going to see the other 2 which are one of the most important techniques. One will be a technique in order to obtain that of your purest semiconductors, and another is a technique which is obtained through your thermal decomposition. So in our next video we are going to see the other 2 techniques of your refining.